All right. Well, thank you everyone for coming tonight. Of course, we are here to go over what the integrated design process is and really, how do you collaborate for a successful new build or renovation? So just a quick agenda. I'm going to give you a brief introduction. We're going to go into what is an integrated design, some familiar examples of successful and some unsuccessful projects. I think you'll see some photos there that are quite recognizable. How do these two approaches between a traditional approach and an integrated approach differ? And how do you include, who do you include in your team for successful IDP? And then I've got a case study of a project that we did here in Whistler that is a great example of a project that I don't actually think could have been built if it wasn't done through this integrated design process. And then we got some time for some questions, and then of course we've got a bar at the back so everybody can hang out a little bit and chat afterwards. All right, so just a brief introduction for me. I'm the president of RDC Find Homes. We've been in business here in Whistler since 1993. We are, I think, the most award-winning local builder. We've got 17 provincial home building awards, and that doesn't include all the finals that we've been to, 3 national awards. We've been included twice in the list of the top 20 most influential builders in British Columbia, and we've been a 2-time winner of the Whistler Chamber Awards for sustainability and including Business Person of the Year. I am still currently a member of Codes Canada. I sit on the Standing Committee for Energy Efficiency, and also have been chairing a number of the task groups for some of the code changes that you'll see coming up in the next 6 to 12 months. I am also the co-vice chair of the BC Energy Step Code Council and a past president of the Home Builders Association, and both past chair for technical research nationally and the Net Zero Council. So can anybody tell me what this building is?
Upper House of 50?
Yes. Anybody know what this is famous for beyond its award-winning architecture?
The roof structure?
The roof structure. Does anybody know the history of this building? Oh, crazy. And so this was a project that was originally envisioned in the late 1940s. The local government of the province and wherever Sydney's located envisioned a place that would be a central place for theater and opera. That would be a signature structure for Sydney. And then in late 1950s, they sent out a design competition, and a young architect from Norway, I believe, won the competition with a very, very basic sketch. And then there was an enormous amount of pressure to get the project moving because they were worried that support for the project could get undermined and canceled. And so they actually rushed into concrete work without actually finalizing the final roof design. And so this was a project that was originally envisioned to start in the late 1950s, like 1959, and be done around 1963, a 4-year project, and had a budget of about $6 million at that time. Ultimately, they didn't finish the project until 1973, and it cost over $21 million. So I think it was about 5 times over budget, 500% over budget. It ruined the reputation of the original architect, and yeah, it was a classic disaster in that there was no real prior preparation before they started construction. So it was the furthest thing from an integrated process. Anybody recognize this one?
Is that the European Parliament?
No, this is the Guggenheim Museum in Bilbao, Spain. And this is in stark contrast to the project that we just looked at. And so this project was envisioned in the late 1980s by the Spanish government. They had a design competition. Frank Gehry won the design competition. And as soon as he got involved, he started to follow an integrated process. So first off, he came out to look at the site that the Spanish government had originally chosen, and they were actually trying to reuse an old brownfield site. He very, very quickly, he was very good at questioning, what they were looking for in this signature museum, and he quickly made them understand that their goals were not well aligned with the location that they had originally chosen. And so then he worked with them to pick this alternative site. And then he went through a very, very thorough integrated process, both with his client, the engineers and the architects, to eventually land on this. It was finished on time and it was finished on budget. And as you can see from the architecture, this is also a very complicated, unusual structure and not dissimilar from the Opera House in Sydney. And is a great example of if you follow this engaged process, you can have predictable, successful outcomes. And then I've just got a few more pictures, Eiffel Tower. And while this presentation is not about prefabrication, interestingly, the Sydney Opera House, the only way they were able to build it is they actually prefabricated all the roof panels. And so prefabrication was, in the end, a successful outcome for them there. This was a project, the original budget for this was envisioned at $6.5 million. The architecture team who eventually designed and built it, they actually did it for $1.5 million. The location is right beside the River Seine. The reason behind that was they created a prefabrication facility upriver. They were able to barge all these huge prefabricated components to the edge of the site and lift them all into place. And so it was a project, this project was delivered on time and on budget. Empire State Building. Does anybody know how long it took them to build the tallest building in the world at the time this was built? It was 11 months. And so again, an architect who spent an enormous amount of planning time, they modularized and designed every single component of the building before they started construction, understanding that when they built this, they were using relatively new technology for this steel structure. And so much like the Eiffel Tower, they were developing new technology to build these new structures, and they were successful because of that integrated design process that they went through intensively before they started construction. And incredible in today's world. I mean, I don't think we see high rises like this built in this type of timeline today. And then, anybody recognize this? This is the Hoover Dam. So this was built during the Depression in the 1930s in the United States. This project, there was an enormous amount of innovation in terms of how they built this. And it came in under budget and 1 year early. And again, it was a project, the lead engineer was very, very focused on getting all of his design completed before they started construction, was very, very well planned out, stuck to their original schedule, and they built something that was the largest dam in the world, and they did it on time. They did it ahead of schedule. Nobody believed actually that they would actually get it built. And he surprised them all by not only building it, but bringing it in a year ahead of schedule. All right, so integrated design process. So, you know, this is, in many ways, it's a philosophy as much as it is a process. As you know, we know in trying to engage people, you have to get people to buy into this. They have to see the end benefit to make this this investment in time up front. We all have clients who are in a rush to get started, and in this way, you know, there's a cost to this, but we have to slow the process down up front to speed it up at the back. And this is a slow down to speed up philosophy here. It is really important that when we do this, you know, we have inclusion of all the stakeholders. And, you know, we have done, it's not a project that I'm going to showcase tonight, but we did a project that we did, I think, a very effective integrated process for about half of the project. Got somewhat complacent, client was in a hurry. And then as the builder kind of got dropped out of the back end of the interior design scope, and that project took a lot longer and cost a lot more than we had envisioned in the beginning. And one of the lessons for me was, if you're going to do an integrated process, you have to do the whole thing. You can't just do a portion of it. You know, part of this idea is this is a collaboration of all the people who are going to work on the project, and you can draw on their collective knowledge for innovation. And so as we look at the Eiffel Tower and the Hoover Dam and the Eiffel and the Empire State Building, those are great examples of innovation that came from within the team that were critical to the overall success of those projects. Of course, on the table today, you hear this every day in the media, is the cost of housing. And so whether we're doing a development of multifamily or high-end residential or an affordable renovation, cost optimization for every single client is top of mind. I have never had a client, no matter what the budget, that wasn't concerned about cost. And so by putting the collective minds together around a table, it gives you an opportunity to work off each other, create those synergies that ultimately result in a better price. And then this is all about strong relationship building, because we know that once we get into construction, whether it's our relationships with our client, our relationships with our trades or suppliers, nothing ever goes the way that you expect it to. There's always going to be a little bit of conflict, but through this process, You build these strong relationships that create trust and communication that get you over these hurdles when things happen that you didn't expect. So this is just a diagram of traditional construction, right? The design team operates in a silo. They develop all their drawings, they tender it out, and it's a very linear process. It's very siloed. You have a client, hires an architect hires an engineer, they submit for a building permit, they tender this out, they hire the lowest bid, and then they rely on the contractor who supplied the lowest possible cost to try and solve all the problems, engage the trades on a fixed price, and somehow, some way deliver to a client on the expectation of cost and schedule and quality. It doesn't work very well. So an integrated process is, you can see that while the design, there is a lot more design at the beginning, the construction team is involved at the very, very beginning. And the design team is involved to the very end of the project. On a traditional build, sometimes the design team is no longer available. There's no budget left. The client doesn't want to pay them any more money. And so then you're relying on the construction team to try and somehow solve all these design issues that they actually never budgeted for in the first place. And so in this way, we have this collaborative process where everybody's working together and everybody can rely on each other from the very beginning to the very end. And so when we're looking at an integrated process, of course, when we looked at the previous linear, siloed, we come down here, we want, imagine this is a table, everybody's around the table, I put the client in the middle, and then everybody else around this table has equal authority. The traditional way sometimes is the architect has all authority, and you do as they say. In this case, everybody has equal input. So your electrician, your HVAC contractor, the interior designer, the builder, planning and engineering, the structural engineer, everybody has an opportunity to bring an opinion to the table for that cost optimization, that innovation, to ultimately deliver what in the end is going to be a better product at a better price. So, what are these key differentiators? So in the integrated process, as we said, it's the inclusion of all the stakeholders. Don't leave people out. Not every partner in the team needs to be present for every single meeting, but there will be big room meetings where you want to have your electrician, your plumber, your HVAC contractor, the interior designer, the architect, the engineer. You may even bring somebody in from the municipality from a planning standpoint so that you really understand if you're designing something that could have some constraints around bylaws and building code. Time and energy is invested at the very, very beginning. And I have a slide a little bit later on that will highlight this. There is an investment up front, which sometimes can scare people. We get pushback from clients who are concerned that they've spent a lot of money and there's nothing in the ground. And that's one thing that you have to work effectively with your clients to get over, is we need to make this investment up front so we're successful in the back end. And then the decision making is made by the greater team. And so nobody is making a decision that doesn't include key stakeholders, because a decision that's made by the interior designer can very negatively impact your heating and cooling design. And we see this all the time, where you have these beautiful houses where the interior design and the architect drove the entire interior finish, and the mechanical contractor was left to try and fit likely the most important feature of the house into these cramped small spaces. You guys were talking, I think, a little bit in the beginning about mechanical room space. I haven't had a project yet where the mechanical room hasn't been under intense pressure to be made smaller. And so if we're looking for an optimized system in terms of creating warm and comfy clients in the wintertime and cool, calm clients in the summertime, then we need to have a centralized system that distributes heating and cooling evenly throughout the entire house and is calibrated in a way that every room in the house has the same optimized temperature. But if you don't include your HVAC contractor and the design at the very early stage so it can get integrated into your interior design, you're always going to end up with these compromises where you have rooms that are freezing cold and you have rooms that are really, really hot. And people, it amazes me what people will put up with in very, very expensive houses. And so, this is an iterative process. When we looked at that circular table shape where everybody is around, as opposed to the linear process that we saw in that diagram where everything's in a silo. And cost optimization is key in every discussion that is had. And so cost is always on the table, and the team is always looking for opportunities to optimize, their collective cost structure. And it's also, in an integrated process, it's an ongoing process. Typically in a traditional process, you have a bid, you win the bid, you build the house, and you leave and you never come back unless there's some real warranty issue. In an integrated process, you're building these strong relationships with your clients and your trades, and you're there on that client's journey for as long as they own that house. And you have built these strong relationships with your trades. And through, this optimized process, everybody has made money. The client's happy because it came in on budget and it was delivered on schedule. All your trades are happy because they had an opportunity to optimize this and they made their margin. And so at the end of the project, because everybody's happy, if there's a problem, they're all going to come rushing back very, very quickly because, they had these strong relationships and they don't want to damage them. Conventional design, as we said, it only involves the members of the expanded team when necessary. Yes, there is less time and less energy put into the upfront process, which makes people feel great because they can rush into construction. But as a builder, and the builders in the room know that time savings upfront bites you at the back end. And so just a picture of, what that team might look like, right? You have our clients in the middle, there's the builder there, phase one is a design, Karina design, interior designer, you've got Capital Home Energy that would be your energy advisor. We'll talk a little bit who that is later. You might, on a complicated project, bring in a mechanical engineer to really make sure that your heating and cooling system is properly designed. You have your structural engineer in Charlton Engineering, and then you have the municipality, recognizing that if it's a simple project, you may not need very much engagement with your planning and building department, but if it's a complicated project, which is what we're going to look at, they become very, very important in these early phases so that you don't end up with a permit application that they won't approve, because that gets very expensive because you've got to go back to the drawing board and do it all over again. And so my philosophy is that for every dollar that you spend in pre-construction, I guarantee you will save at least $2 in construction. And so that upfront investment becomes very, very valuable because when you're talking of tens of thousands of dollars, you're talking exponential savings through the construction process. So this is an example of a project that we built. I think we started design in around 2017, went to permit in 2018, started construction in the fall of 2018 and finished around 2022. So this is a render of what the final design was approved, working with Stark Architects here. And this is a rough massing model that we did at the very beginning. And so some of the constraints on this is that, as you'll see in the next slide, the elevation from where the back tires of the truck is up to the roof of the house is over 65 feet. When we look at these lines here, as we'll see, well, actually, I don't have a picture of it, but the house is designed to the minimum side yard setbacks because the lot was incredibly narrow at the front and widened at the top. And so it created enormous complexity in terms of how do we actually build the house, because once the bottom of the house is in place, we can't actually get equipment around the sides because we would be on the neighboring property. The steep slope also had enormous complications, and then we had a house sitting on this side over here. And in doing the excavation, we were going to actually undermine the foundations of the existing house. And so this cross section really just shows you, you're at 722 meters here, and then down at the bottom, we're 704 meters, and that's not even at the base road elevation. So incredibly challenging. And then with the RMOW's rules around roof height, if we had to design a house that actually fit on the lot and maximize the opportunity for the gross floor area calculation, we ended up with a roof height calculation that was over double what the allowable roof height calculation was. And so we worked very, very carefully with the planning and building department to come up with a design that they would agree to. And they looked at the bylaws and said, okay, this lot could have an auxiliary building. And so we'll consider this as an auxiliary building. And so it has one roof height calculation. And then we'll consider the main house as a secondary building. And its roof height calculation will then come down to the average grade, which is the lowest place for the house. And one of the things that we actually were able to do with them was typically if this was an auxiliary, if these were two buildings, they would have had to have had two separate foundation walls. But because we understood the constraints that we were dealing with, we were able to negotiate with the RMOW, and we were able to build both structures off one central retaining wall. And you can imagine, this retaining wall goes up 3 stories. This is a very expensive piece of concrete. And if we'd had to do this twice, literally we would have had one wall here, and we would have had another wall there. But because we had this engaged process with the RMOW from the very, very early stages of the project, we were able to come to this optimized design that literally saved thousands and thousands and thousands of dollars. And so, for me, I actually think that if this had not been executed through an integrated design process, the likelihood somebody might have looked at this lot and said it was unbuildable. Another component part of this, as you'll see in the next photo, is at the early design stage, we hired a mechanical contractor and we executed all the mechanical design for this. So as you look at this, there are no drop ceilings here. This is the underside of the roof trusses. And we were able to do that because we understood what the mechanical requirements and limitations were. We were able to design in a proper mechanical room, on the lower floor here, and ended up with a really optimized mechanical design that has worked very, very well at a very good price. Of course, one of the other key partners in today's world with step code requirements in British Columbia is we need to meet an energy requirement within the building code. And so I can't emphasize how important it is to bring your energy advisor into the earliest stages of your concept design, because while the step code can be relatively easy to meet, in certain circumstances, if you design a house that has a lot of articulation, a lot of corners and jugs and jogs, and has a lot of windows facing north, has very, very tall ceilings, you could actually end up with a design that you cannot comply, that will not comply, particularly as we get to the higher levels of the step code, step 4 and step 5. And so bringing your energy advisor in at a concept stage so you understand what you might need to make that compliant envelope is really, really important. And this is just an example of the final rating. So this is a 6,000 square foot house. Granted, it is built into the hillside. It's because this is the report from the house we were just looking at. But it has a modeled energy use of 42 gigajoules. So for a house of this size, that's a very, very small amount of energy use. So just a little more context. This is the lot prior to any construction. It almost doesn't look like there's a lot there. That could be the house on my left and the house on my right could simply be 2 lots that met in the middle. And so some context, that's the lot with the trees taken off of. This gives you some context of how high this was. So, somebody standing down here in the excavator, way, way, way up in the air. And then there's a shot of concrete works. And so through that integrated design process, the team quickly started to understand that we would be unable to build the concrete from the bottom up because the concrete at the bottom would limit the machine's ability to get around and do backfill. We couldn't get a pump truck that was big enough if we didn't have access into the bottom of the lot to pour concrete on the top walls. There were all kinds of constraints like this. And so we worked very, very carefully with our geotechnical engineer, our excavation contractor, and the structural engineer to design the structure so that it could be built from the top to the bottom. And this was a very, very carefully coordinated exercise. There was a neighbor who was a civil engineer who ran a big civil engineering firm. His business was building bridges. Before he retired, he told me 2 things. He said, this project is more complicated than most of the bridges we ever built. And I actually thought when you started this that it couldn't be built. And I thought, you were doomed to failure. And so that's why I highlighted this particular project, because for me, it really was a great example of how that integrated process could create a successful project in a situation where somebody might have shown up and said, actually, I don't think you can build, if you had gone through that traditional process, designed in a silo, and then gone to get planning and building department approval, you absolutely would have been sent back to the drawing board and had to redo it. And had you had a completed design and then gone out to tender, and somebody hadn't really clearly understand the constraints they were dealing with, and had put a fixed price bid on this, the outcome likely would not have been good for anybody. Because you can always find somebody who will offer a low price, right? And there's the completed project at the end. And so I've got a few other slides here just they are also reflective of an integrated process. This is a project we finished a year ago. Again, we had a very thoughtful and detailed process with the homeowner to develop a new home. They had a very, very tight budget. They were adamant that they could not go over budget. And so, the design is somewhat simple looking, but this was entirely based on one, they were looking for a very modern contemporary house, and they were very, very focused on their retirement and having something that was affordable. This was on the last phase of Wedge Woods up at the top. I don't think we were necessarily the first house to go on the ground, but this was the first house that was finished in that new subdivision. And so that upfront time where we weren't the first in the ground, we were by far and away the first to complete well advance of any of the other houses. And yeah, it was done in, I think, around 9 months, and it came in exactly on budget. This is another great example of the integrated design process. You can see the sort of A-frame structure on the bottom. That was the original house. This was the finished structure. This was actually a renovation. The client came to us early days, and he wanted a new house. And he wanted to be in his house for Christmas of 2022. And so we started this discussion in the spring of 2021, and we knew that we couldn't start construction until January based on our permit wait times. And so it basically gave us about 11 months to do the project. And so having that engaged conversation, he understood, we understood what he wanted. We were able to tell him what his limitations were. Interestingly, the house that you see next door, so we finished this at about the same time as this house was finished. This house, I think, started in September of the previous year, and we finished about the same amount of time. Well, we finished on the same date, just before Christmas of 2022. And so, yeah, with this project was finished in 11 months. It started in January with demolition. We prefabricated all the wood framing components. All the timber frame was also all prefabricated. One of the fascinating things for me was the creativity that the team brought to the prefabrication process because they knew they were under such a tight timeline. And so one of the first experiences we had, all these roof sections were all prefabricated on the ground. It saved an enormous amount of time. That work was done while other work was ongoing. This roof went on in about 4 hours. And then we worked with a great timber frame outfit out of Squamish. They prefabricated all of these components. My team had originally considered doing the install within the RDC team, and they had scheduled a week to assemble all those components. By working with the team that did the original timber frame works, they actually assembled all this in 1 day. And so again, great example of that collaborative relationship, looking to optimize the process and picking the people who are best suited to do the work. All right, and that's that. Got done a little bit early. Questions? Yeah.